Today we're going to begin nuclear radiation, and you've already seen an introductory video from TED Ed about different types of nuclear radiation, and today I'm just going to go over some definitions and the different types of radiation and radioactivity. All right, so just some basic definitions that you need to know. Radiation is a form of energy that comes from elements that are radioactive, that have an unstable nucleus. Okay, a radioisotope is an isotope of an element that emits radiation. Okay, and then there are a few different types of radiation that I've got listed here. An alpha particle is just like a helium nucleus. So the symbol for an alpha particle is the helium with the 4 at the top, meaning it's got a mass number of 4, and 2 at the bottom, meaning it has 2 protons. So since we know it has 2 protons and the mass number is 4, that means it must have 2 neutrons. Okay. A beta particle is another type of radiation, and it's basically a high energy electron. So it has a charge of -1, and the mass is small, so we do not, we just put the mass number as 0. So the symbol for that is the E with a 0, and then at the bottom, since there's not a proton, it has the opposite charge. We put a -1. Okay. A positron is very similar to a beta particle, but it has a +1 charge, but its mass number is still essentially 0. So it has the same mass as an electron, but it has the opposite charge. Okay? And then finally, gamma rays are just high energy radiation. So we learned about gamma rays back when we learned about the electromagnetic spectrum. So you should remember that they're very high energy and very dangerous to our health. So to summarize this just in picture form so that it maybe is a little bit easier, an alpha particle is 2 protons and 2 neutrons in a nucleus, and that is one particle that can be emitted from an unstable radioisotope. A beta particle is essentially just an electron with a lot of energy, and the way that gets emitted is we have a neutron in the nucleus, and it gets converted to a proton. So our products are a proton, so the mass number of our isotope does not change when it undergoes beta emission, and then we also have an electron that's emitted. So the charge of the species or the radioisotope changes, but the mass does not. Okay, and then positron emission, that's the opposite. So if we have a proton in the nucleus, we can have that emit a positron, which is basically the positive charge from that proton, and it gets converted to a neutron, and then the positron is just released from the atom. And then the last one is a gamma ray. And a gamma ray is just energy. It doesn't actually change the nucleus of the radioisotope at all. So this here is just a table that summarizes everything I just told you, the charge and the mass number, and it also summarizes the change to the nucleus that happens when this form of radiation occurs. Okay, and then the radiation protection table that I have down here, this just summarizes how dangerous these particles are and what you need in terms of shielding to protect yourself from them. Okay, so alpha particles are the biggest, and so they're least able to penetrate things because they can't get through even paper or clothing. Okay, so you need the least amount of shielding for an alpha particle. A beta particle is much smaller than an alpha particle, okay, and is therefore a little bit more dangerous than an alpha particle is. They also move farther because they move faster since their mass is smaller. Okay, and then the most dangerous kind is going to be gamma rays, which are, they can go through clothing, they can go through your skin, and they can travel quite far. So those are the most dangerous, and you need rather thick shielding in order to protect yourself from gamma rays. So for all of these nuclear reactions, we can categorize the radioactive decay using chemical equations, okay? And so for, just as a definition for radioactive decay, since I've been saying this, that's when the nucleus spontaneously breaks down and emits radiation. So radioactive decay can be any of the kinds of decay we just talked about. All right, so for the example of alpha decay, if we had uranium-238, for example, and that will just spontaneously undergo radioactive decay. And if it undergoes alpha decay, then one of our products has to be that helium particle or the alpha particle. And then the other product must change according to how much the mass and the number of protons changed when we took out that helium. So if our mass was 238 and we took out a mass of 4, our new mass for our product is 234. And our number of protons was 92, but 2 of them went with the alpha particle that left. And so now our new nucleus has 90 protons. And so we went from uranium to thorium. So anytime the number of protons changes, we're changing the identity of the element. Now we can do the same thing for beta decay. So to write a reaction for beta decay, one of the most common elements that undergoes beta decay is the isotope of carbon that has a mass of 14, okay? And so part of the reason that is unstable is that it's got too many neutrons for the number of protons that it has. So the type of decay that it undergoes is beta decay because that causes one of the neutrons to be converted to a proton. Okay, so the mass of our nucleus does not change because the beta particle has almost no mass. And then we actually gain a proton because one of the neutrons is converted to a proton. So this generates a new element, which we, in this case, is nitrogen, because that's the one that has one more proton than carbon. And then the other product is the beta particle. And part of the reason we write this the way that we do, the symbol for the beta particle the way that we do, is it makes the math work out. So 7 plus -1, which is what we have over here on the right, gives us 6, which is what we started with on the left. Okay, so those numbers always need to add up on both sides of our equation. All right, and I'm not going to go through this chart, but this is just a helpful guide for you to figure out if it's undergoing each of these types of decay, what is the product that you get out.